Okay, so yeah, thanks for everybody for attending. I'm actually really excited to introduce the 8360 series to you guys. There's been a lot of hard work getting this to market. So let's kick it off. We're just going to go through an overview, of course, of the 8360, get you guys introduced to it, and then, of course, go through some use cases, and then, of course, dive into the operation and troubleshooting procedures for the 8360. So, as an overview, so this is really our first Aruba Gen 7 ASIC designed for data center top-of-rack switches, as well as campus aggregation environments. And it's a series of switches that actually gives us a lot of flexibility because we have smaller port density and various port densities and port types. So we have, well, as a whole, of course, all of the 5 switches are non-blocking architecture, and we've got 10, 25, and 100 gig options. And of course, not surprisingly, we've got both airflow options, so front to back and back to front for all of these. Of course, hot swappable fans and power supplies, and of course the rack kits, and of course these have the USB-A and USB-C console interfaces that we're familiar with. It supports the Bluetooth and the mobile app. And then another interesting thing is there's a model that actually has some MACsec ports, so we have 10 and 25 gig MACsec capability on these switches. And of course, not surprisingly, VSX, VXLAN, and of course, when we're releasing them, they're all going to be running on the 10.6 code. Taking a little closer look at them, so it's 5 switches, starting from the top. This is an option that gives us a 100 gig low density type switch. So this is an 8360 12C, so it's 1200 gig ports. Of course, this could be seen as a small spine switch, or of course, even a aggregation switch in a campus environment. And then next we have 2 models that support 25 gig interfaces. So we have a low and medium density option for a 32 port option of 25 gig with 400 gig uplinks. And then we have another option with 16 25 gig interfaces and 200 gig uplinks. And then of course we have a base T option. So this is our 48 port 10 gig base T with 4 ports of 100 gig uplinks. And then finally, we have a 24-port 10 gig Qsfp Plus option that gives us also 200 gig uplinks. When we're looking at the power supplies of these switches, so the power supplies, all these switches are actually bundled in a single SKU. So when the customers order them, it's just going to be a single SKU. It'll have the fan trays and the power supplies bundled into them. But these are orderable for RMA. And you can see the 2 different power supplies that are populated in these switches. So we have the red tabbed ones, JL600A. This is indicating that hot air is being drawn out of the power supply. So this is indicating a port to power or front to back airflow solution. And then of course we have JL712A with the blue tab indicates that cool air is being drawn in. So it's a back to front or a power to port solution. As I mentioned, these are the N+1 capable, they're hot swappable, and each one of them are maximum power consumption is 500 watts. Now, if one power supply fails, it's important to note that the failed power supply must stay installed in the switch so that it doesn't disrupt the airflow within the switch. And very similar for the fan trays. So the fan trays, again, are bundled in with the switch, but here we have 2 orderable SKUs for RMA type scenarios. So JL714A with the red tab, of course, is the port to power airflow, and JL715A with the blue tab is the power to port airflow. Now, in the case of a fan failure, the other fans will increase their speed and operate at 100% indefinitely. And it's just like with the power supply, that failed fan should stay in the switch until it gets replaced with a proper fan. Of course, if we remove it from the switch, that creates an air gap, and of course, that'll disrupt the airflow in the switch. So with regards to the airflow operation of the switch, this is configured every time the switch boots up. So it's not a configurable option at the CLI. What the switch does is it's going to match whatever airflow direction the PS1, the power supply, and power supply slot 1 is configured for. Or if power supply in slot 1 is not present, then it would look at the power supply in slot 2. And if the fans don't match that airflow, then CX is going to disable it. So really, what that means, if the customer does want to change the airflow directions on these switches, they'd need to order new power supplies and fan trays, and then of course the whole switch would need to be shut down and rebooted back up. Now I mentioned that these are bundled, so the SKUs here on the left for the 5 models are the base chassis SKUs, but the SKUs, of course, on the right are the bundled SKUs that include the fan trays and power supplies. So we have the front to back options, and then of course we have the back to front options. Makes it easier for the customers to order them when they're bundled like this. But it's important to note, though, that the rack kits are not included with any of these bundles. So that is one thing that the field needs to remember, is to add a rack kit with each of these bundles. Of course, we have a 2-post route kit and a 4-post rack kit, mostly seen in the data center environment. And that brings me to another point. So if you've noticed on that first slide, like we have these switches that have 16 ports, 32 ports, yet look at the dimensions of the switches. The dimensions of these physical boxes are all the same. And there's a purpose for that, in that we can actually allow them to use this single air duct, which we're also going to be introducing with the 8360. So this allows us to ensure that there's more optimal airflow going through a back-to-front airflow mounted switches, because of all the server hot air that gets rises up through that rack. This air duct will help us ensure that we're getting cold aisle air drawn into the switches, making it more optimal. Another thing to note with this air duct is it can actually be used, because of the dimensions, and it can actually be used with the 6300 back to front out of band switch in the data center also. So it's compatible with that one also. So what's with base T? So what are the issues with base T? So we have the 8360 48 port base T model, and then of course we've got our base T optics. The 48 port base T model, take note that the 100 meg ports, they don't support half duplex. So they're gonna just parallel detect automatically to 100 full duplex, and we don't support setting a forced mode. And with the 100 meg and 1 gig configured ports, the FC counters will not be accurate. So the flow control counters will not be accurate. This is a Tele1 issue, but this is going to be addressed in a later ASIC role with the Tele2 ASIC. With the base T optic, so the 10 gig base T optic and the 1 gig base T optic, those are fully supported on these switches. Just know that we don't support setting the forced mode. It's auto negotiation only, and each of these optics support only a single speed. So the 10 gig one only supports 10 gig, the 1 gig one only supports 1 gig. The one restriction on the 32 port model, this is the one that has 4 MACsec ports. The first 4 ports are the MACsec ports. Those ports only operate at 10 gig, so they're not going to operate at 1 gig with these base T optics. So those are the only ports you couldn't install a 1 gig base T optic in. And a link level flow control is not supported on all of the 8360 models. So regarding to splitting the ports, well, actually, let's talk about LRM. So the 8360 series, they don't support the use of 10 gig LRM or 7-meter DACs. So take note of that. And then with regards to splitting ports, all of the ports can be split, and all of the ports can have the speed set independently. So like with the 8325, you know, we have the port groups of 12, and all of the ports in those port groups need to be the same speed. We don't have that issue with the 8360, with the exception of those 4 MACsec ports. So the 32 port 25 gig switch, the first 4 ports are all MACsec capable, and those ports must all operate at the same speed, and their options are either 10 gig or 25 gig. So that's the one port group that we have. And then with regards to the splitting ports, as I mentioned, all of the ports can split except the 48 port base T model. That's the one caveat. That model does not support splitting the 100 gig ports. We still do have to reboot when we split the ports on the 8360, but we're looking to resolve that with 10.7. And when we're talking about these split ports, of course, the HIT split cables that were introduced in the 10.5 scenario are these currently supported split cables. And then also, just like we introduced in the 10.5 scenario, unsupported transceiver mode is supported on the 8360. Just like with 10.5, this applies to transceivers and DACs, but only at 1 gig and 10 gig. 25, 40, and 100 gig are locked out. And of course, the documentation is available on the Aruba transceiver guide. So for use cases with 8360, this is going to be seen in the data center a lot as a small spine scenario, or of course as a leaf, obviously operating as leafs, providing 25 gig connectivity to the servers. That 10 gig base T1 will be used a lot for server connectivity. We're introducing Rocky V2 capability with the 8360. So as you can see on the chart on the bottom, we're looking at Rocky V1 solutions, which are supported on the 8325, the 8360, and 8400. But Rocky V2 solutions, so these are routable, lossless Ethernet-based solutions, those are now going to be supported on the 8360 and the 8400. Of course, it also supports EVPN and VTEP functionalities, so this is going to be used both in the data center environment, or of course in the campus environment using VNBT. And as I mentioned, it supports MACsec, so we do have options with MACsec on here, so we're going to be seeing scenarios where we're using this to secure, let's say a dark fiber DCI scenario, or maybe we're securing various building-to-building traffic across a campus, or even across floors within the same campus environment. And I think I'll turn it right back over to Ruben. Thanks, Ruben.
Oh, Ruben, you're still muted.
Okay, thanks, Steve. And let's start looking at the operation. So there's, let me see one thing here. Someone that had raised their hand. Looking at that. Okay. Okay, let's keep going. If you need to ask any questions, please put them in the Q&A panel in Zoom, so we can answer the question, but also it gets recorded so we can share it later with the larger teams. So, operation of the 8360s. Let's go a little bit. Let's take a short look at the different aspects of operating these devices, and then we'll get a little bit into the system and troubleshooting, and Matt will take that part. So in terms of management interfaces, physical interfaces to manage the device, we have to see, you know, there are a couple in the front and there's one also in the back of the switch. And this is the same for every model. All models are exactly the same in terms of these interfaces here, and all the, actually, the cabinet itself it's very similar or exactly the same among all of them. So externally, you'll find the same elements in the same places for all models. So in the front panel, we have an out-of-band management port, which is a 1 gig Ethernet port. It's a host port, as we all know. Then we have an aux port, which is a USB-A port, and that is the one that we can use along with the Bluetooth adapter for you know, configuration using the mobile app. And then we also have in the front a USB-C port that is there for console connections. In the rear panel, we have a second console connection for you know, an RJ45 serial connection. And you can have both of them connected at the same time, but in that case, what you will be doing is you will be able to enter commands on the front console port, the USB-C port, and the output of all those commands will be mirrored. So you will get the output on the, you know, on that connection that you're entering the commands, but you'll also get the output on the other console port. So the rear console port will also, will only behave as a an output interface at that point. If you need to, what you will do is disconnect the front console port, and then you will be able to use the rear console port normally. So we had a question about why would you do this? Why do you have these two? Normally, you will have your rear console port, the RJ45 serial port, connected to your terminal server. And then if you need to do a quick connection, you will get to the front and use a USB-C cable to connect to the switch and use that. Do you need any particular drivers for the USB-C port? In general, yes, but it will depend on how you have your PC configured initially. I usually use my phone with a USB-C to USB-C cable, and I have a serial app in my phone, and I can use that for initial configurations or some quick changes, and I didn't need to put any drivers on my phone in particular, and that's an angle.
Yeah, sorry, Joe, but the driver for Windows is actually the URL for that driver download is in 4 slides from now. Yep. So we will have the link in a later slide.
Exactly. Mm-hmm. In addition to all of that, we have the luggage tag that we have in other models and in other switch series. The only switch series in which we don't have this is the 8400, but we have this in every other device. And this is really nice because it allows us to get to the serial number and the MAC address in a very simple way without having to remove the switch from the rack. So the USB type A port, the aux port, can be used for different purposes. The one that we usually use for marketing is to use the Bluetooth dongle. And it's actually very, very useful. And so you can use that along with the mobile app, the Aruba CX mobile app, to do either an initial configuration or a quick configuration change if you have to. Then the other way of using it is to use a USB drive, and then you can use it to exchange files, in particular to upload new code or to save configuration files. And that would include configuration files or even support files, right? So all of that can be done via the aux port or the management USB port. To access the USB-A drive, you will insert your device in the USB port, and then here you have the commands on how to mount your USB device depending on if you are running the service OS or if you're already running CX on the device. So here you have the different commands for that. The USB-C use cases, here you have the link to where you can download the driver. So that's what Matt was mentioning a few minutes ago. And it will depend on the cables and the device you're using to connect to the console. Indicators, LEDs. We have these basic indicators in the front and back, and we'll go through the details in the next few slides. So first of all, in the front, we have a global status or health indicator. Then we have a unit ID or locator LED. And then we have a speed indicator and 2 user indicators. And then in the rear panel, you have 2 sets of indicators. You have the global status again, above the console connector. You have another locator LED, and then you have indicators to show which fans are inserted and running in the same with the power supplies. On the fans and the power supplies, you will find other LEDs to show you the actual status of each one of those components. So let's go one by one here. The global status or health indicator. This is a global indicator that will tell you if everything is okay on the whole unit. And you have one in the front and one in the back, just so you don't have to be walking around the racks to see that. This will, if it's in flashing green, it's when everything is okay in Service OS or Aoscx during the startup, and then in normal behavior in Service OS, it will keep flashing in green. And then in Aoscx, once everything has finished booting and the system is working normally, it will be in a steady green. Then if it's flashing in amber, then that means that there's something wrong in the whole switch. And then you will have to go and find which other LED is also flashing in amber. So that could be a port that is detecting some fault, or it can be one of your modules, you know, field replaceable units like the fans or PSUs. So you will have to go to the back of the device and check that. In Service OS, if you're running this in Service OS, once the Service OS has been accessed and completed its upload, then there will be nothing shown in terms of faults. It will keep flashing in green. So there's no fault indication on, you know, the health indicator when you are in Service OS. The locator LED, this is something that we know from all of our previous devices, and this is something you can turn on to find your device on the racks, right? If you are in a very large environment, for example, a large data center, if you want to find what switch you are connecting to and you're trying to debug or configure, then you can turn that on and you'll find the device quickly. And that will be there for 30 minutes, or actually you can say how many minutes you want it to be on. In the back, you have another status indicator, but you will see that, so if the back indicator in the front is flashing in amber, that means that there's something wrong in the back. So that will suggest that you walk around and find what's wrong in the back. And it's usually one of the modules, either a fan tray or a PSU. Fan status, you'll find on each one of the fans, you'll find one health indicator or health LED, and that will be in green if it's working normally, and it will be in amber. It will be showing an amber color if it's either an illegal fan, and I'll tell you what we mean by that in a second, or if the unit is faulty. So by illegal fan, we mean that you have a fan there that doesn't match the airflow. So if, for example, the switch is having a back to front airflow and you insert a fan that is front to back, it will be illegal and it will not start. So as we already discussed. So in terms of ports, this is the same as we have in older or other members of the CX family. You'll have these indicators, and normally when you are doing the startup, this is, I'll get back to your question, Deepak, in a second. So during the startup, all the ports are off, and they come and start blinking in green when there's traffic. And when it's in green, either flashing or half bright, it's because there's a valid link. So whenever there's no valid link, there's no connection there on that port, that LED is going to stay off. So if there's a fault, it will keep flashing, but it will change from green to amber. Something similar happens with Qsfp ports. Remember that we have, all the models have either 2 or 4 Qsfp 28 ports. Depending on the port density, you have 2 or 4. But also, because they can be split, remember that there is one exception to that. There's one model in which you cannot split the Qsfp port into 4 individual ports. But in the cases in which you can, you see that you have 4 LEDs. And if they are not split, then all 4 LEDs will be blinking at the same time. And but if you split the port, then you'll have one of these LEDs indicating the behavior of each one of the individual subports. And then, you know, the colors and the status of that, each one of those indicators is the same as we saw before for individual SFP ports, either SFP plus or SFP 28. I have something similar for the out-of-band management port. And we have also something similar for the aux port. So for the USB-A port. And as we said, we have individual LEDs for each one of the power supplies and the individual fans. So again, green is good, amber is, there's some issue there. So when we say when it's off, it's usually because it's inserted, but it's not powered. So after all of that, I will turn it over to Matt, and we'll get into system and troubleshooting.
Thank you, Ruben. All right, so I'm just going to go ahead and jump right into this. So just kind of give you an overview of the system environment in Aoscx. And I should note that this is not specific to the 8360. This is generic to all Aoscx switches, but especially if you haven't worked this closely with Aoscx before, this will be a great kind of introduction to the basic architecture of the Aoscx system itself. So there are 4 major components in the 8360 system environment. The first is U-boot, which is the bootloader for the switch. This component contains basic instructions to set up the CPU and system devices prior to the next step in the boot process, which is loading the switch service OS. Service OS provides system maintenance functionality, including zeroization, as well as automatic in-system programming or auto ISP functionality for updating programmable devices in the system. These include the switch PHYs, the PoE controllers, anything that has its own firmware that can be updated while the switch is running. The auto ISP feature is responsible for performing those updates and checking the integrity of the firmware of each component. I should note this also includes the bootloader and service OS itself are components that can be updated by this process. And one of the functions of the service OS is to load, verify, and start booting the actual Aoscx switch software itself. So Aoscx is the switch software environment, fully programmable network operating system that runs not only the 8360, but all of the Aruba CX switching line from the 6200 all the way up to the 8400 chassis switch. And then finally, you have Bash. This is the Linux shell that's part of the underlying operating system that Aoscx was built on. This provides additional tools for debugging and troubleshooting and can be accessed both from Aoscx as well as from the service OS shell itself. So we have a little diagram of the connections between the different components in the software, from the bootloader through the service OS. The service OS, when you're actually booting a switch, and I'll show this in an upcoming slide, provides you, if you're connected via either the RJ45 or USB-C serial consoles, gives you the option to select the software image you want to boot, either the service OS console for performing maintenance or troubleshooting, or either the primary or secondary Aoscx software images, at which point it boots into the selected option. You either get the service OS login prompt, or the switch will boot into the Aoscx software image, launch all of the processes, and then present you with the product OS prompt. The shell is referred internally as the VTY shell. And either of these, when you log in, either the service console or the Aoscx software itself, you have the option to open a shell session to bash to access the advanced troubleshooting and debugging tools. Helps to be in the PowerPoint window. So the power on boot process, a couple of prerequisites. You have to have, obviously, at least one power supply installed and powered on for the switch to operate. Now, the system airflow direction is determined if you have both power supplies installed, or power supply 1 is the only installed power supply. That will be used to determine the system airflow direction. So whichever model of power supply you have, either back to front, port to power, or power to port, that power supply will be used to determine the airflow direction for the entire switch. If power supply 1 is either not installed, if you only have power supply 2 installed, or if PS1 is present but not powered on, then power supply 2 will be used to determine the airflow direction. To change the power supply, or to change the airflow direction, you have to actually power the switch off, remove all power supplies and fans, and exchange them for power supplies and fans for the airflow direction you desire. So if you want to switch from power to port to from a back to front to a front to back power supply, you have to actually physically power the switch off and exchange all of the power supplies and fans so that they all match your desired airflow direction. Second prerequisite, you have to have a minimum of 3 operational fans. If you do not meet that requirement, a fan fault will be logged by the fan daemon, and a warning message will be printed to the screen if you have less than 3 operational fans. As noted, all installed fans have to match the system airflow direction. So any fans you have installed that don't match the switch running airflow direction will be disabled and not count toward that 3 fan minimum. So that will be logged as a fault until the fan, if it's a failed fan, it's replaced, or if it's a fan that doesn't match the airflow direction, until you replace it with the proper airflow fan. While the switch is booting, the global status LED will flash green until the Aoscx portion of the boot process successfully finishes its self-test initialization. So this is an example of what you can expect to see during the boot process, and I will have a brief demo after my presentation showing what the boot process actually looks like live. So there's 2 different types of ways of initiating the boot of a system. The first is the cold boot. This is powering on the switch from an unpowered state. So you've either unplugged the switch to power it back on, or you've just taken the switch out of the box, or it's been unplugged for a while and you're powering it on. This is referred to as a cold boot. A note for power supply swapping: power supplies are hot swappable. However, you should never install a power supply that is already connected to AC power. You should always unplug the power supply inlet before actually installing in the switch. This prevents any possibility of arcing or any other undesired behavior from damaging the contacts on the board where it interfaces with the power supply. The second type of boot is a warm boot. This is any type of reboot that is initiated by software on a running switch without disconnecting power. So there's three main ways this happens in Aoscx. The first is issuing a reboot command in Service OS. That can be entered either from the Service OS shell or from the login prompt itself. So if you're at the Service OS boot login prompt, you can enter reboot as the username, and it will reboot the switch immediately. So you don't actually have to log in. Second way is to use the boot system command from Aoscx. And you can designate which boot image you want to reboot into, either the primary or secondary Aoscx software images, or if you're connected to one of the console ports, you can actually reboot directly into Service OS to perform some sort of maintenance on the switch. If you don't explicitly specify a boot target, the switch will use the current default boot image, either the primary or secondary, with the primary being the default. The last main type of reboot source is the auto ISP process. So when you are rebooting the switch into a new software version, if it has any programmable device updates that are a part of the new software, as those updates are being installed while the switch reboots into the new image, additional reboots will occur after each of those devices are updated. So if the Service OS is updated, the switch will reboot as soon as each Service OS image update completes to activate the new component firmware. And that generally happens for all devices that are updated on the switch. Command line interface access on the 8360. For serial console access, you have the option of either the back panel RJ45 serial console port or the USB-C port on the front of the switch. For either one of those, you would need to have the appropriate adapter or cable. In the case of the USB-C port, any standards compliant USB-C to C or USB-A to C cable will work for that. I believe it is a USB 2.0 compliant serial adapter behind the port. The driver was linked in an earlier slide for Windows, so you will generally need to have that installed if you're accessing this from a Windows device. The serial console, both USB-C and RJ45, is fixed at 115/200 baud, just like every other Aoscx device. This differs from AOS Switch in that the older platforms had an auto-sensing baud rate. So when you connect it to the switch and hit enter twice, it would auto-detect your baud rate anywhere from 9600 to 15200, and that's what it would use until you disconnected from that session. RJ45 is on the back, USB-C is on the front. If you are connected to both of the console ports simultaneously, USB-C port on the front takes precedence over the RJ45 on the back, as noted by Ruben earlier. So only the USB-C console will accept input, but both ports will mirror the output from all commands that you're running and any boot output from the switch. The second main method for accessing the CLI is the management session. This can be primarily over the out-of-band management port, which is dedicated for switch management purposes. Does not participate in any routing or traffic forwarding on the switch, so it's isolated from the rest of the switch ports. Supports 10, 100, 1000 meg. And to enable it, you must have a connection to the switch, generally going to be over the console port if you don't have OBM configured already. And then you you enable the port and configure an IP address, either DHCP, static IP, and this supports IPv4 and IPv6. So 8360 troubleshooting, starting with the basic system environment. So the first step whenever you're having an issue with the switch is to identify what portion of the system the issue is occurring in. Is it the bootloader, Service OS, or Aoscx itself? If the issue is occurring in bootloader U-boot, typical symptoms of this are going to be you're not getting any console output from the switch at all when power is applied, or you get the switch is looking for Service OS but is never able to successfully load it. These are indications that there is an issue with the bootloader itself. And in these conditions, generally the only thing you're going to be able to do is have the system serviced by Aruba. There isn't really any user level troubleshooting you're going to be able to do to recover a switch from a bootloader issue. Second type of issue may be the service OS. So in this case, you may get the service OS boot menu. If you're monitoring the switch from the console while it's booting, you may see the boot menu, but the switch never actually boots to Aoscx, or it boots directly to the service OS login prompt without any input. So generally, it will only ever boot to the service OS login if you initiate a boot system service OS from Aoscx, so you've intentionally rebooted the switch to service OS, or the system is not able to load either the primary or secondary Aoscx software images. So in either of these cases, you would need to log into service OS and recover the system, which is most likely going to require zeroizing the switch and reloading software images to recover. The third major system environment where you're likely to encounter issues, and this is probably most likely in an operating switch, short of a hardware failure, is Aoscx itself. Generally is going to be caused by configuration issues, environment issues, but more likely than not, it's going to be a configuration issue causing this. So if you have a switch hanging during boot, if the switch boots fully but you're unable to log in, if the switch is operating but is having unexpected performance issues, traffic's being dropped, routing isn't behaving properly, or if you're actually seeing process crashes, these can either be due to configuration problems, physical infrastructure issues, miswiring, bad cabling, or they can actually be bugs in the OS themselves, specifically in the case of process crashes. So down here we have definitions for the different boot environments, which I pretty much already went over in the previous slide. So general troubleshooting steps. How can you tell if there's an issue with the switch just kind of eyeballing it? Well, the first step, check the LEDs on the front if you have physical access to the switch. Is the global status LED flashing orange? Are you seeing fan or power supply indicators on the back panel flashing or solid orange? Are your port LEDs lit up as expected? If you have links that are down or links that are flapping, LEDs are a good way to start your visual troubleshooting. And if you know what the switch is supposed to be looking like, then you can cross-reference that with the behavior you're seeing when there's an issue to identify possible causes. Check the installation method. How has the device actually been installed? This can be potentially a cause of heat dissipation issues. So if you have a non-optimal airflow configuration, so let's just say you're doing back to front airflow, but the back of the rack is actually the hot aisle, not the cold. So the switch is sucking in hot air. That could be causing issues. If you have your vents obstructed, you have any fans failure, those can also cause issues. If you have configuration issues that you're unable to resolve through typical troubleshooting methods, let's just say the customer has been playing around with their switches and they have actually made some changes in bash, just playing around with the system, and they've accidentally done something to the database in bash that doesn't show up in the CLI and can't be fixed there, then your last resort may be actually zeroizing the switch. Zeroization removes all configuration, logs, event history, everything gets blasted away from the switch. The only thing that's saved are the software images themselves. And I'll go over the zeroization process in a later slide. But as this notes, this should only be performed as a last resort because nothing is preserved other than the software images themselves. So if you need to collect any troubleshooting data before doing this to attempt to resolve the issue, do it beforehand because you're not going to be able to collect anything afterward. The switch will basically be returned to a factory default state. So your next tool for troubleshooting is event logs. So there are lots of types of logs that are provided in by Aoscx itself. the most basic and the first one that you're most likely to refer to is the main event log. So all system events are logged to the system event log with a timestamp for every event entry. So this allows you to review those logs for general switch performance to see what the switch is doing at any given time, but also obviously for troubleshooting specific issues. You can filter the event logs a number of ways by types of failures. So you can filter by a specific string if you're looking for a specific keyword in the logs to tell you what might be going wrong. You can filter them by severity. So if you only want to see error logs, you can do that. Or you can show logs from a specific Aoscx system process, such as the HPE Isp, which is the in-system programming process. So if you want to use the event log to verify to see what updates have been performed on the switch, you can do that. For system Isp update history, another option you have for that is to use the show tech commands. So you have show tech by itself generates a whole mass of technical information that is typically used for submitting TAC cases or by somebody who really wants to take a look at the total status of a switch at the time the command is run. You also have the subcommand show tech update specifically to take a look at update history from the Isp logs on the switch. The third option is to collect support files. This basically generates an archive of all system and debug logging on the switch at the point the command is run. It will generate basically a zipped up archive that you can copy off of the switch either to a TFTP, SFTP server, or to a USB drive to be submitted to TAC, because this is typically going to be used in the case of generating TAC cases for troubleshooting on our end. Transceiver or DAC issues, these are another common thing that will pop up. So things to check for, are the transceivers or DACs being detected properly? So check the output of show interface brief, show interface transceiver. If you're physically at the switch, look for link lights, look for flashing indicators. Any unexpected behavior there, make sure they're seated properly. Make sure they're being properly identified by the switch. So obviously not all transceivers are supported. So any third party or an unsupported first party transceiver will be reported as unknown or unsupported under the transceiver status of one of these two commands. They will not be able to establish a link or pass traffic. Even supported transceivers may not function properly depending on the system configuration. So in the case of, and in particular, the MACsec capable models, the MACsec ports use the interface groups, as do the, just like the 8325 25 gig models. So if you have, and those default to 25 gig. So if you're attempting to use a 10 gig transceiver in one of the MACsec ports and you haven't explicitly set the interface group speed to 10 gig, those transceivers will not work. So what you'll get is a flashing link light until you set the proper interface group speed. And then make sure you have 10 gig base T transceivers only in supported ports. Link or traffic issues, they see link status changes, performance degradation. This can indicate a bad transceiver or a bad optical cable or a bad DAC. Use event logs to check for status changes. So if you have interfaces are transitioning more than you expected, that could be an indication of a bad transceiver or cable. Check configuration, make sure there are no config conflicts. This goes back to interface group speed in particular. And does the issue correspond to a particular time of day, event, transceiver or DAC combination, or feature configuration on the switch? These are different things that you can check to troubleshoot these issues. Getting a little more onto the kind of the system maintenance side, programmable device updates. So anytime you update the switch to a new software version, that software image, that .swi file, may contain updates for different components that, that make up the switch overall system. This includes the bootloader, service OS, the PHYs, the PLDs, basically all the different components inside the switch that have their own individual firmware components. Those can all be updated by the system, and when those updates are made available, they're contained within the switch software image, and they are run, those updates are run when the switch is rebooted into that new image. There is one exception to the automatic update policy. All components are updated automatically with the exception of the bootloader itself. The bootloader is what we consider an unsafe update. And what we mean by that is if the update, while it's being run, if it's interrupted for any reason, if you accidentally unplug the switch while it's in the middle of updating that bit, you may render the switch unbootable. So for that reason, those updates are not enabled by default, and you actually have to explicitly enable those before the switch will install them. And you do that using the allow unsafe updates command. This temporarily enables these types of updates for a period of 1 minute up to 2 hours. And once you run that command, you have that amount of time to reboot the switch and allow it to install those updates. Once that time limit expires, that feature disables itself again, and those updates will no longer install automatically. So when you run that command, get the admonishment here telling you when you actually run this command, you first need to wait for all line fabric modules to reach ready state. This is more for chassis switches. Reboot the switch to begin applying needed updates. You can check to see if any updates are included with a new software image after you've loaded it into Flash, but before you reboot the switch using the show needed updates command. Next boot, primary or secondary, lets you specify which software image to check for any available updates. If you don't specify one, just like the boot system command, it'll use the default image as the source to check those updates. Next, we have zeroization. So this is a way to securely erase all customer data from the switch and restore the switch to a factory default state. This could be run by an admin user from either the Aoscx shell using the erase all zeroize command, or from the service OS shell using simply erase zeroize. If you run this from Aoscx, the switch will reboot to service OS, so you will need a console connection to monitor the process. What will happen is when the zeroization process starts, the switch will back up both the primary and secondary software images to RAM. It will zeroize the file system, so it'll flip the bits, all the bits on flash 0, 1, 0 to completely zeroize all customer data. And then it will restore the software images once it's formatted the file system post-zeroization, and then the switch will reboot itself once again in a factory default state. So the only thing that will be retained when you zeroize the switch are the software images themselves. Everything else goes away. It'll be just like you took the switch out of the box, except for the software versions used will be those that were present when you zeroized. You must not power the switch off until it's complete and software images are restored. If you do, the file system will be gone, so the switch will have nothing to boot from. So you basically leave the switch completely unbootable. Takes about 2 minutes, and once again, everything goes away. All logs, all support files, everything. So make sure you get all of it before you zeroize the switch. Before we move on to energy efficient Ethernet, I do have a brief demo to run. So I'm going to go ahead and connect to my 8360 here. There we go. Let's make this full screen. And I'm going to start with the event logging here. So let's go ahead and do, first of all, let's make the paging a little bit better here. And let's just do a quick show events so you can see what the basic event log looks like. So show events. And so this is the format of the event log. So you can see you have everything is time stamped, basically down to the millisecond plus level. You see the host name of the system process generating this log. So this is the name, this is the actual Linux process that is running, that's generating all of these entries. You see event. This is just an event. I believe this is a process ID right here. The severity level. So most of these are info severity. This is active management module. This is the system, basically chassis slash module version. Since it's a standalone chassis, it's always going to be 1/1. And then the actual content of the event log entry itself is last. There are a number of ways you can filter these. So if you do show events, and we do the question mark to see the syntax, you could show event logs from all boot cycles that are currently retained on the switch for a specific event category, for a specific daemon, event IDs, a specific number of logs. /R is very useful because this shows the event log in reverse order. So newest events show up first, whereas default, it's oldest events first. So basically from initial boot is where the event log starts. And then you can filter by severity. So if I do show events /R to show the newest, here we just see a bunch of login sessions. So we have an application that is authenticating against the switch every 5 minutes. So that is basically filling up the event log here. So let's do severity. And I want to filter out all of the info messages. So let's just go ahead and do notice. And there's not really much happening to this switch at the moment. So it's basically running the entire event log and only displaying the lines that are notice level and above. If I want to, let's go ahead and try a different one. So one of the examples I provided earlier was showing the HPE Isp log. So let's do all log entries because we haven't had any updates in a while. And then let's do by daemon, HPE-ISP, and it will show all HPE ISP log entries from all previous boot cycles. So here we see updates for the Service OS primary image from old version to new version. This is a prototype switch, so it was running prototype firmware when we first booted it up. We see Service OS secondary, we see the U-boot, and here we see this interesting notice: do not interrupt non-fail-safe update for module MC device U-boot single. This is an example of one of those unsafe updates that you actually have to explicitly enable on the switch in order to work properly. Let's go ahead and do show tech. If we want to get a little more detail about what that update entails, let's go ahead and do show tech update. And this shows the actual source logs for the HPE Isp process. So this is where we get all of the detailed logs on what is actually happening when these updates are being applied. So if we go ahead and see here, we can see the command that the system is actually running during the boot process to apply these updates. So we see Service OS primary, we see old version, we see the new version, the image file name, we see version upgrade needed, automatic updates disabled. So the first time the switch was booted, these updates were actually disabled and they were not being run. So let's go ahead and move a little further down. Here, the update's actually being applied. So we see version upgrade needed, starting update. This is what you'll actually see if you are monitoring the boot process while these updates are occurring over the serial console. This is actually what you're going to see during this process. You'll see each of these updates being installed, and the switch will reboot after each one of these. For the U-boot update, for the unsafe update, this is what you will see in this case. This is warning you not to interrupt this update. Don't unplug the switch for any reason while one of these updates are installing, or you may end up with an unbootable switch afterward. More update components. In the case of some of these components have a primary and secondary piece inside the switch. In most of these cases, what's going to happen is it will update the secondary first, reboot the switch into the secondary component, and update the primary and reboot back so that the primary is updated last rather than first. This is very similar to how VSX Live Upgrade works, where it will update the secondary first, reboot, and then switch over to that while it updates the primary. Exactly the same process there. So that's updating. Now let's go ahead and drop into Service OS itself. So let's do boot system Service OS. This warns you that access to Service OS is only available for the serial console. That's how we're connected. So we'll go ahead and say yes. It's going to reboot the switch, which will take a minute here. I don't see any active questions. And once the reboot happens, we'll see the bootloader starting up, locating and loading the Service OS image, and then we'll get dropped into the Service OS prompt itself. So here's the bootloader. The first thing you see is that little dot. If you're powering a switch on and watching it as the watching the console, that dot is the first thing you'll see. Then looking for Service OS, loading the primary Service OS image, and here's our Service OS menu. Right now you see this profile selected is Service OS console. Normally this would be either the primary or secondary software images. So here we go. So you have the option of rebooting without logging in, but we're going to go ahead and log in. Service OS by default does not have a password set. You can set a password from the Aoscx side itself. Go ahead and see what commands we have available. So here we have, this is basically your utilities are available from the Service OS prompt itself. If you were to need to load a new software image onto this switch, you have the option of using the out-of-band management port to do that. First of all, we can take a look at the status of that port by doing IP show. It is disabled in Service OS by default. You can do IP DHCP to just have it get a temporary DHCP IP address. And if we do IP show again, it will eventually, if there's a DHCP server available on there, then you will eventually get a DHCP address. If there's no DHCP address, then you use the command IP static. And I have to take a look at the syntax because I haven't done this in a while. It's actually IP address, and then you would assign it a static IP address from there. In this case, what I'm going to do instead is I'm going to drop down to the bash shell. This is where you can do any additional troubleshooting you need. You can, if you have to, you can use this to recover software images using a TFTP server. So you would assign the switch an IP, and then you would actually use TFTP server. So syntax is TFTP get, so -G for get, -R for the remote file name. So in this case, you would load a software image like ll10.06.01.swy, and then the target IP address, so 10.10.10.1. This is just an example. Obviously, I'm not actually going to be able to connect to this because I don't have an IP address on the switch, but that's the syntax you would use. And then once you actually have your switch image loaded, then you use the command update. If I want to update the primary software image, you do update primary, and then the name of the software image locally. So LL10. And if you've actually loaded the software image and you're just specifying the file name, you can actually use tab autocomplete to finish the file name if it up to the point where it matches. 601.swi, and then it will replace if the primary software image with the one you've loaded. If there is no primary software image or no secondary software image, then it will simply copy this into place, verify it, and then that switch software will be available to boot. Lastly, what you can do is you can zeroize the switch from here. So to do that, you simply do erase, zeroize. It'll give you the warning. It will securely erase all data, reset the switch to factory default. So it will reboot itself back into Service OS to zeroize it, and then reboot it in a factory default state. So I'm just going to go ahead and say yes, just to show you what this actually looks like. So let's take a few seconds to locate and load Service OS. And it will automatically boot into Service OS and start the zeroization process, which will take a couple of minutes. So preparing for zeroization is backing up the software images to memory right now from flash, and now it's actually zeroizing the file system. So this says it should take several minutes to 1 hour to complete. It actually doesn't take that long on any of our current switches. The flash is actually a pretty decent speed on most of these. So what it does is it zeroizes it and then reformats the flash, so it restores the file system structure and then restores the software images once that has been completed. So what you end up with is a functional system with the software images and a default configuration. I don't see any questions. This should be done momentarily. And then once it does that, restore the images, and it will reboot itself automatically. And since it'll be in a factory default state, once again, it will boot to the primary software image. I'm actually going to hijack it and boot it to the secondary, because the secondary image is actually the one it was running before we did this. There we go. So it's restoring files. Zeroization itself is done. And then once files are restored, automatic reboot. And then I will hijack the boot menu and send it to the secondary image. There we go. And there we go. So there's our secondary image. One thing to note, it will print this out. Once again, this is a prototype switch, so the settings for the ISP configuration are different from production switches. So I'm going to scroll this up here to lock it in place a bit. So note how it says auto updates are disabled, which is the default. Unsafe updates not allowed. Auto updates are enabled on all production switches. Unsafe updates are disabled by default on production switches. So this setting is different. So updates will install automatically on customer purchased hardware. The only stuff that requires a specific command to install is the unsafe updates, which is basically the bootloader. Here we are, back to login prompt, factory defaulted switch. So here we see 8360 login. And if we log in as admin, no password, then we get the prompt to change our password immediately. And that's all I have. So hopefully you got some good information out of that.